For months, astronomers assumed that 3IATLAS was nothing more than a routine traveler from the depths of space, another cold drifter slipping through our solar neighborhood with the same indifference as a stone carried downstream by a river that never thinks about its destination. It looked small, it sat far away, it moved quickly, and while it certainly carried an air of mystery, it was never expected to matter. But then the numbers began to murmur. Those murmurs turned into recognizable shapes, and eventually those shapes revealed something far more disturbing than anyone expected. A deviation appeared tiny, yes, but undeniably real. Its trajectory shifted by nearly 100,000 kilometers, a change so statistically improbable that even the most cautious orbital specialists began second-guessing their own models. And what made this even more unsettling was the direction of the shift. It did not sling the object outward into the empty void, nor did it knock it into some chaotic tumble. Instead, the alteration nudged 3IATLAS with unnerving precision toward the unseen frontier of Jupiter's gravitational territory, the Hill sphere, a region where the gas giant's pull dominates over the suns, and where objects can drift, quietly caught as if within a delicate gravitational trap meant to hold them indefinitely. This was never meant to happen. Not naturally, not easily, not statistically. The likelihood of a perfect rendezvous like this is 1 in 26,000. A figure so tiny it starts to resemble choreography more than coincidence. And when you factor in the other strange elements, its minuscule nucleus no larger than the Vatican, the enormous coma spanning hundreds of thousands of kilometers around it, its survival through an encounter with the sun that should have shredded it, the blurry early photos that sparked speculation, the unusually high CO2 content, and the tale that refuses to behave like a normal cometary tale, the entire situation begins to look less like scattered clues and more like pieces of a puzzle that were never meant to be separated. Yet here they are, drifting in front of us, demanding to be put together. The shift was so subtle at first that most astronomers simply brushed it aside, treating it as another tiny curve buried in background noise. But as new observations poured in and researchers fed the updated data into their orbital models, the deviation refused to fade. Instead, it sharpened into something disturbingly consistent. 3IATLAS had altered its trajectory by roughly 100,000 kilometers during its perihelion passage, the very moment when the object should have been fighting for survival against the sun's most intense heat. This was not supposed to be a moment of control. It should have been pure chaos. When a comet swings close to the sun, solar radiation melts surface, ices unleashes violent jets of sublimating gas, and pushes fragile interstellar bodies to their breaking point. That kind of energy normally sends objects spinning unpredictably or cracking apart. Yet Atlas did something that defied the playbook. Its shift was not erratic. It was smooth, directional, and aligned almost perfectly with a new trajectory pointing straight toward the outer edge of Jupiter's Hill sphere. And this is where the statistical nightmare begins. The chance that a random interstellar visitor not only survives a sun plunge, but also adjusts its path in a way that lands it nearly perfectly on the boundary of Jupiter's gravitational domain is 0.385%. When numbers drop, that low chance stops feeling like chance. You start to wonder if something else is involved, intention, or at the very least, some unknown force we do not yet understand. Every typical comet from our own solar system suffers near the sun. They crack open, they fracture. Their nuclei burst apart under thermal stress like frozen stones hurled into a fire. Even large and dense comets struggle to stay intact. But 3IATLAS, already tiny at barely 1 kilometer across, should have been even more fragile. Instead of being torn apart or shedding massive fragments, it emerged from its solar encounter intact, perfectly intact. Its survival is not just odd, it is unprecedented. At first, many scientists believed Atlas had disintegrated entirely when early blurry images mistakenly identified another comet, Cone Atlas, as the shattered remnants of our interstellar traveler. But once the confusion was cleared up, the truth was far more unsettling. 3IATLAS had endured the kind of heat and tidal forces that should have ended it. So the questions become unavoidable. What kind of internal structure holds together that strongly? What sort of material withstands that kind of punishment? And why is a nucleus so small, behaving like something built with purpose, rather than something thrown together in a distant icy nursery by chance? Early assumptions painted Atlas as a massive interstellar heavyweight, an enormous comet carrying vast frozen reservoirs. But that picture collapsed the moment more powerful telescopes got a clear look. Beneath its astonishingly large coma lies a nucleus so tiny it almost defies logic, less than 1 kilometer across, roughly the scale of the Vatican. And that discovery changes everything. A nucleus this small should not be capable of generating a coma so enormous. Yet Atlas surrounds itself with a cloud of gas and dust, stretching far beyond what any local comet with similar size could produce. For a core that small to create a coma more than double the diameter of Earth, its composition would need to be extraordinarily saturated with volatile ices, far richer than what we typically find in our own solar system. This immediately raises uncomfortable questions that cut deep into the foundations of planetary science. How does such a tiny object survive a close brush with the Sun? How does a nucleus barely 1 kilometer wide produce a coma spanning hundreds of thousands of kilometers? And what kind of chemistry is necessary to sustain something so extreme? Whenever an interstellar visitor carries properties never observed in our own cosmic backyard, it becomes more than just an object. It becomes a message, a sample from a planetary nursery shaped by rules completely foreign to us. But perhaps the strangest feature of 3IATLAS is not its nucleus at all. It is the atmosphere around it. Atlas possesses a colossal CO2 coma stretching nearly 350,000 kilometers in all directions. This is not remotely normal. Comets in our solar system usually release water vapor dust and only trace amounts of CO2. Atlas, by contrast, releases carbon dioxide in quantities that dwarf every recorded comet, both local and interstellar. This imbalance hints at an origin far colder and far more extreme than anything orbiting our Sun. Even stranger is the way the coma behaves. Instead of swirling chaotically the way cometary gas normally does, Atlas maintains a surprisingly stable and structured envelope, almost as if something is controlling or regulating the outflow, rather than letting it erupt freely. This is why scientists remain so divided. Nature is usually messy, but Atlas behaves like it is following rules we do not yet understand. One of the earliest controversies surrounding Atlas had nothing to do with its chemistry or trajectory, but with its photographs. When NASA first released the images, they were so blurred and lacking detail that many people wondered if they were looking at smudges on a camera lens instead of a true interstellar object. But there was a reason for this. The instruments capturing those images were never designed to track something so faint, so distant and moving that quickly. They are meant for data collection, not beauty shots. Still, the timing could not have been worse, because the release of these low-quality images was delayed partly due to the United States government shutdown. Speculation spread like wildfire. Why were the pictures so unclear? Why did they arrive late? Why did they reveal almost nothing? But once more capable telescopes Hubble, Webb, and the Vera Rubin Observatory turned their eyes toward Atlas, the truth became clearer. The nucleus was simply too small to capture sharply, and the coma was so diffuse and enormous that it provided almost no contrast. Even with high-resolution instruments, Atlas remained a challenge to image. Yet even in the improved photos, one unsettling mystery persisted. The tail of Atlas did not look like the tail of any comet ever catalogued. Its curvature, its brightness, distribution, and its alignment with the pressure of solar radiation all deviated from established comet physics. A tail that refuses to behave like a tail is not a meaningless quirk. It is a clue. Atlas is only the third confirmed interstellar object to enter our solar system, following Oumuamua and Borisov. And like both of its predecessors, it arrived carrying questions instead of answers. Borisov acted mostly like a comet, but with unusually intense volatility. Oumuamua behaved like nothing we had ever studied, accelerating without visible outgassing and tumbling like a flattened shard of metal. Atlas seems to combine the strangest aspects of both. It has the hyperbolic trajectory of an interstellar traveler, the chemical anomalies of a foreign comet, and the dynamic oddities of something that refuses to match natural expectations. When you put together its extreme survivability, its tiny nucleus, its massive coma, and its unpredictable tail, you stop feeling like you are studying a comet. You start feeling like you are studying a question. Atlas's origin can be traced back toward the constellation Sagittarius, a region pointing near the galactic core, where stars form in crowded, turbulent environments, and interstellar chemistry becomes far less predictable. Whatever gave birth to Atlas was nothing like our own Sun. It emerged from a place where gravitational forces collide, swirl, and shape objects under conditions we barely understand. Its velocity tells us everything we need to know. Atlas was never bound to our solar system. It came from somewhere else entirely, flew through the darkness between stars, and is destined to leave again. Interstellar visitors are supposed to do exactly that, pass through, unbothered, uninterested, and unchanged. But Atlas seems determined to break that rule. Instead of simply slicing through our planetary system and disappearing into the void, it appears to be making an intentional brush along the edges of Jupiter's gravitational influence. That is the part that truly unsettles astronomers. Visitors do not take scenic routes. They do not slow down to sample the scenery. They certainly do not adjust course. Yet here we are. The probability of any comet, much less an interstellar one, passing within the boundary of Jupiter's Hill sphere by chance is 1 in 26,000. That number is not just small, it borders on narratively suspicious, as if the cosmos rolled a die-ice and it somehow balanced on its edge. When events line up, this perfectly coincidence stops feeling like coincidence. It begins to resemble breadcrumbs. During its closest swing around the Sun, Atlas experienced a non-gravitational acceleration. NASA attributed this to jets of gas escaping from its surface normal comet behavior. But the direction and strength of that push were so precisely aligned that they placed Atlas almost exactly on a path toward Jupiter's Hill sphere. The Sun's heat should have produced chaotic bursts, not a clean, deliberate adjustment. Yet what occurred looks eerily similar to a course correction, and the timing raises even more eyebrows. This shift happened while Atlas was hidden behind the Sun, completely outside our direct line of observation. When changes happen in the dark, people start asking questions. Avi Loeb poses the one question that many consider outrageous until they study the data. If Atlas is not behaving randomly, then why Jupiter? His reasoning is surprisingly simple and deeply unsettling. Jupiter is the gravitational superpower of our solar system. Its Hill sphere is enormous. Its Lagrange points are stable for ages. It is visible from almost anywhere in the galaxy. If an advanced civilization wanted a discrete, long-duration way to deploy observational probes into a new star system, they would not target Earth. They would not target Mars. They would use Jupiter. In that interpretation, Jupiter becomes a cosmic harbor. Atlas becomes the delivery system. On March 16, 2026, Atlas is expected to slip within roughly 53.44 million kilometers of Jupiter, a distance almost identical to the size of the planet's Hill sphere at that moment. The alignment is so precise that even skeptical astronomers admit it is impossible to ignore. If Atlas is nothing more than a natural comet, then this will stand as the most extraordinary coincidence ever recorded in cometary science. But if it is not purely natural, then this approach becomes something else entirely, the perfect delivery window. Avi Loeb speculates that Atlas might be positioned to release small, autonomous probes, the kind that do not look anything like science fiction spacecraft. Not glowing orbs, not saucers, not dramatic machines. Instead, quiet devices designed to remain dormant unless triggered. An advanced civilization would not waste energy launching large active ships. It would hide them inside objects that resemble comets, using physics and gravity to do most of the heavy lifting. And if Atlas releases anything at all, we might not see it immediately. The probes could be microscopic. They could be metallic. They could be dark, cold, and effectively invisible tiny machines meant to slip unnoticed into Jupiter's gravitational web. The more astronomers refine Atlas's orbit, the stranger the situation becomes. The trajectory is not drifting away. It is tightening. It is focusing. This is the sort of behavior you see when something is following either a natural process we have not yet discovered or a design far more deliberate than we are used to imagining. Even skeptics struggle with how many unrelated anomalies point toward the same outcome. At some point, coincidence stops behaving like coincidence. Not all scientists are ready to embrace exotic explanations. NASA maintains that the trajectory can still be interpreted as extreme, but natural comet behavior. The outgassing models, while stretched to their absolute limits, remain technically possible. The tiny odds of a Jupiter near pass, while incredibly low, are not mathematically forbidden. And Atlas's survival near the Sun, while baffling, does not prove artificiality. But the real test is coming soon. The spectroscopic data expected during the December 19, 2025 flyby will determine whether the jet patterns and chemical fingerprints align with natural comet activity. If they do, the mystery shrinks into a rare but natural case. If they do not, then everything changes. We now find ourselves hovering on the brink of something unprecedented. Every new update nudges Atlas closer to Jupiter's gravitational frontier. Each fresh image uncovers yet another inconsistency, and every refined model tightens its already unnerving trajectory. Soon we will have to face one of two possibilities. Either Atlas is a natural but extraordinary miracle of interstellar chemistry, or it is something far more provocative. A visitor with intention, a messenger carrying design, a courier traveling with secrets older than our sun. In the end, everything funnels down to a single, unavoidable fact. 3IATLAS is headed straight for Jupiter, and that should not be happening. Not by chance, not by physics, not by probability. It survived a solar encounter it should never have lived through. It remains intact when it should have fractured. Its tiny nucleus should not be able to create such a massive coma. Its acceleration is too precise to be random. And now it is approaching the edge of the largest planet in the solar system with a level of accuracy that feels scripted. If absolutely nothing happens, then we simply expand our scientific understanding of comet behavior. But if something does happen, then humanity will have to reconsider its understanding of itself. After examining every anomaly, every deviation, every improbable number, and every unresolved question surrounding 3IATLAS, we arrive somewhere that feels less like a conclusion and more like a doorway, a narrow threshold between the universe we think we understand and the universe that may have been trying to speak to us all along. Because when you assemble the evidence, the 100,000-kilometer course correction near the sun, the survival that contradicts comet physics, the tiny nucleus wrapped inside an enormous CO2 atmosphere, the tail that refuses to obey solar wind behavior, the early blurry images that concealed more than they revealed, the perfect approach to Jupiter's hill sphere, the 1 in 26,000 probability, and the whispers of possible devices waiting to be released, you begin to realize something important. This story was never just about a comet. It was about perspective. It was about the way the cosmos sometimes forces us to reconsider the things we too quickly label as harmless, random, or ordinary, when in reality they might be anything but. 3IATLAS sits in a place where explanations split into two towering possibilities, one built from the limits of natural physics, and the other from something far more deliberate. NASA's models still technically fit within the boundaries of natural comet behavior, but only if every extreme happens at the same time. Extreme sublimation, extreme statistical coincidence, extreme survivability, extreme chemical composition. If you stack enough improbabilities together, you can still call the result natural. But at some point you have to ask, are we chasing the truth or protecting our comfort? Because standing opposite that increasingly unstable tower is a far bolder idea, one that does not require fantasy or science fiction imagery. It simply asks whether Atlas might not be acting alone, whether its chemistry, its acceleration, its timing, even its trajectory could belong to a process older, quieter, and more deliberate than anything our species has ever encountered. This possibility does not demand visions of massive alien starships or glowing craft hovering in the dark. The idea is much simpler, almost elegant. A probe concealed inside an object that imitates nature. A passive messenger drifting silently through interstellar space for centuries. A courier designed to awaken only when a gravitational giant like Jupiter enters its zone of opportunity. But here is the truth we must live with for now. We do not know. We do not know whether Atlas is the most extraordinary natural comet ever discovered or a visitor with purpose. We do not know whether its approach to Jupiter is a cosmic coincidence or a scheduled appointment. We do not know whether March 2026 will pass quietly or leave behind something small, dark, cold, and patient in Jupiter's gravitational wake, watching our solar system, the same way we watch the stars. What we do know is this: 3IATLAS has already changed us, because objects like this do more than rewrite orbital charts. They rewrite the way we look at the universe, the way we trust our instruments, and the way we understand our place in the cosmos. And maybe that is the real message hiding under its giant coma and its impossible tale, that the universe is not silent. It speaks through signals, not speeches. And sometimes those signals arrive wrapped in ice disguised as coincidence, appearing like something we think we have seen before, but never truly understood. As we wait for the December 2025 flyby, astronomers around the world are preparing their spectrometers, calibrating their telescopes, and counting down every day as Atlas inches closer to Jupiter's hill sphere. The clock is ticking in silence, but the anticipation grows louder with each update, because at this point one truth can no longer be avoided. We are not just observers in this story. We are participants. Whether Atlas behaves exactly like a natural comet or reveals something completely unexpected, The outcome will push humanity one step deeper into the ongoing conversation with the universe, a conversation we may not even realize has already begun. The December encounter will show us the chemical fingerprints of its jets. The approach toward Jupiter will show us whether its trajectory continues tightening or finally begins to drift. And by March 2026, the mystery will either collapse into the realm of natural physics or expand into something far larger. The question is no longer whether we are ready for that answer. The question is whether the answer has already been unfolding around us. If this journey through the unknown has pulled you in, if it has made you question the nature of cosmic visitors, or stare at the night sky with a deeper mix of wonder and unease, then do not let the story end here. Subscribe so you will not miss the next update as this mystery evolves. Turn on notifications because Atlas is moving quickly and the next anomaly could appear without warning. Share this video with someone who still thinks comets are simple, predictable, harmless things. And leave a comment telling me what you believe. Is 3IATLAS simply an extraordinary comet? Or is it the opening page of a much larger message? At the end of this long investigation, after analyzing every anomaly, every improbable shift, and every unanswered question surrounding 3IATLAS, we stand at a place that feels far less like a conclusion and far more like a threshold. Narrow doorway between what we think we understand and what the universe may have been quietly trying to show us for years. Because when all the evidence is gathered together, the 100,000-kilometer course correction near the Sun, the survival that breaks the rules of comet physics, the tiny nucleus wrapped inside an enormous CO2 atmosphere, tail that refuses to follow, solar wind logic, the early, blurry images that hid more than they revealed, the perfect alignment with Jupiter's Hill sphere, the 1 in 26,000 probability, and the faint hints of possible probes waiting to be deployed. You start to realize that this was never just the story of a comet. It was always the story of perspective. The cosmos has a way of forcing us to reevaluate things we casually label as random, harmless, or unimportant, when in truth they might be anything but. 3IATLAS challenges us because it stands at the boundary between the explainable and the impossible. NASA's models still fall within the realm of natural physics, but only if every extreme occurs at the exact same time. Extreme chemistry, extreme survivability, extreme coincidence. At some point, we have to decide whether we are assembling explanations or avoiding the uncomfortable. And opposite that fragile tower of improbable natural events stands a bolder question. What if Atlas is not acting alone? What if its chemistry, its acceleration, its timing, and its near-perfect path toward Jupiter belong to a plan something older, quieter, and more intentional than anything our civilization has ever encountered? This does not require alien motherships or glowing machines. Sometimes the simplest idea is the most unsettling. A probe hidden in an object that looks like nature. A silent traveler drifting for centuries. A courier waiting to awaken when a gravitational giant like Jupiter enters its window of opportunity. But right now, one truth remains. We do not know. We do not know whether Atlas is the most extraordinary natural comet ever recorded, or a visitor with purpose. We do not know whether its approach to Jupiter will be an incredible coincidence, or an appointment kept across light years. We do not know whether March 2026 will pass quietly, or leave behind something small, cold, dark, and patient, watching our solar system the way we watch the stars. What we do know is this: 3IATLAS has already transformed us. Objects like this do more than rewrite orbital charts. They rewrite our relationship with the universe and with ourselves. And maybe that is the real message hidden beneath its colossal coma. The universe does not whisper in words. It speaks in signals. And sometimes those signals arrive disguised as coincidence. So as we wait for the December 2025, flyby astronomers fine-tune their instruments, prepare their spectrometers, and track every new data point, while the silent countdown toward Jupiter's Hill sphere keeps ticking in the background. With each passing day, Atlas draws closer, and the weight of that approach becomes harder to ignore. Because at this stage, one reality stands clear. We are not merely bystanders to what is happening. We are woven into this unfolding story. Whether Atlas proves to be entirely natural, or reveals something that stretches the boundaries of our understanding, the result will push humanity deeper into the cosmic dialogue we have been participating in, whether we realized it or not. The upcoming observations will tell us how its jets behave. The chemical signatures will reveal whether its activity follows any pattern we recognize, And by the time March 2026 arrives, we will be forced to face the truth whichever direction it leans. Will this object slip past Jupiter with nothing more than a breathtaking coincidence? Or will it leave behind a clue, a trace, maybe even a device resting quietly in Jupiter's gravitational net? We do not have that answer yet, but one truth is becoming impossible to overlook. 3. Atlas has already shifted our perspective long before it reaches the gas giant. It has reminded us that the universe is active, dynamic, and capable of surprises we are not always ready to accept. It has challenged our assumptions about interstellar visitors, forced us to reconsider what qualifies as coincidence, and nudged us toward thinking bigger, maybe even more bravely about our place in the cosmos. Perhaps the real significance of Atlas is not what it might be carrying, but what it has already delivered. A renewed sense of curiosity, a spark of awe, and a humbling reminder that we are part of a much larger story. In the end, the real question is not whether we are ready for whatever Atlas reveals. The real question is whether the conversation has already started, quietly, subtly unfolding around us, long before we realized we were part of it. Because 3IATLAS has done something remarkable, not just in its trajectory, not just in its impossible survival, not just in its chemistry or its coma, or its perfect drift toward Jupiter's hill sphere. It has changed us. Objects like this do not simply adjust orbital charts or update astrophysical models. They shift the way we look at the night sky. They reshape the questions we dare to ask. They remind us that the universe is not silent. It communicates through patterns, coincidences, anomalies, and rare events wrapped in ice and dust. As the December 2025 flyby approaches, and as astronomers aim their instruments toward this enigmatic traveler, one truth lingers. We are not just watching the story unfold, we are stepping into it. And when March 2026 arrives, one of two things will happen. Either Atlas glides past Jupiter as the strangest natural comet ever recorded, or it leaves behind something small, quiet, and waiting a witness resting in the gas giant's gravitational cradle. Whatever the answer is, Atlas has already nudged humanity deeper into the cosmic conversation. So if this journey through the unknown has kept you curious, if it has made you think differently about cosmic visitors, or stare at the sky with a hint of wonder or unease, do not let this be the end. Subscribe so you will not miss the next chapter of this unfolding mystery. Turn on notifications because Atlas is moving quickly, and the next anomaly could appear without warning. Share this video with someone who still thinks comets are simple and coincidences are harmless, and let me know in the comments. Is 3IATLAS just an extraordinary comet, or the opening line of something much bigger?